I'm Kirsten McCormack, as Luke has told you, and welcome to my takeaway talk titled Alexa, Make Me More Money. I'm going to cover what I believe are the most important aspects regarding cloud migrations that are not always explicitly discussed when first investigating and upskilling in the topic. This includes a strong focus on the why and what of the topic. Why are you considering cloud computing as your solution? What is your specific use case? Where and how do you hope to see the benefits of this migration? If it's purely cost reduction, you're approaching this topic wrong, but we'll get to that. First, let's demystify the whole concept of the cloud and its greatest value proposition. Then I'll cover the premise of a data lake and its value in business before covering the most important aspects of cloud migrations, strategic thinking and planning. Cloud computing offers the ability to deliver on-demand computing services over the internet on a pay-as-you-go basis. This is the compute as a service model, and it is the keystone of anything cloud-related. It is based on the premise of multi-tenancy, which means that multiple clients can share the same computing resources. Despite the fact that they share resources, cloud customers aren't aware of each other, and their data is kept totally separate. This compute as a service model gives rise to three different cloud service models: infrastructure as a service, platform as a service, and software as a service. Unlike the rigidity of on-premises solutions, cloud computing is perfectly scalable and elastic. By outsourcing data storage and management to the cloud, upfront hardware costs are entirely avoided, and you only pay for what you use when you use it. This scalability also leads to sustainability, as you're only ever using the energy you really need. Previously, you would have had to upfront the cost of your servers and purchase a finite amount of compute capacity, which would go unused for most of the day or become too little too quickly, leading to stress on the system. Now, you can't think about anything cloud-related without thinking big data. The entire cloud revolution is fueled by the big data evolution. Walmart generates 2.5 petabytes of data every hour, and by 2025, more than 25% of all data created will be generated in real time. Real-time data is information that is delivered immediately after collection. There's no delay between the source and the storage and the analysis. Implementing a big data pipeline in the cloud provides you with fully managed complex data processing workloads that can handle varying loads automatically. This means that businesses can rethink what data they store or weren't previously storing due to cost concerns. Without a big data pipeline, it would simply not be possible for institutions like Walmart to gather and process such a continual stream of data. I personally believe that the true value of cloud computing lies in its native support for deep learning via frameworks such as TensorFlow and Apache FXNet. The scalable, fast, and relatively cheap GPU computational power, combined with the big data pipeline, means that training and deploying accurate artificial intelligence and machine learning models that deliver real-time data insights is more achievable now than ever before. At the core of the discussion on how to leverage cloud computing to increase revenue is data monetization. What businesses need is a fast and efficient way to get meaningful information from their data gathering efforts. This brings us to the concept of a data lake. Although relational databases make our data easy to query, data must be ingested in a structured, predefined schema. The data lake, however, is a centralized repository that enables organizations to gather, manage, enrich, and analyze many new sources of data, as is, whether structured or unstructured. Unlike relational database management systems that require expensive hardware and skilled human resources to implement and manage, data lakes store data in its raw format, which means less upfront setup costs for ingestion, and transformation. It enables organizations to treat data as an organizational asset to be gathered and nurtured versus a cost to be minimized, transforming their data into a source of business value generation. An Aberdeen survey saw organizations who implemented a data lake outperforming similar companies by 9% in organic revenue growth. However, it's imperative to ensure that your data lake doesn't become a data swamp. Since raw data is stored with no oversight of its contents, it is important to ensure you create adequate crawlers that run through all the data and create a data catalog that can easily be queried and understood. The catalog assigns a unique identifier to each element marked with a set of metadata tags. With the help of crawlers and ETL jobs built into the data pipeline, visualizations are updated in real time upon addition of new data into our data lake. The data lake powers new types of analytics, like machine learning using previously unanalyzed sources, such as log files and clickstream data. This allows for quick and informed decision-making, leading to revenue growth. You probably require both a data lake and a data warehouse, however. A data warehouse is a repository for structured, filtered data that has already been processed for a specific purpose. Cloud solutions generally implement both a data lake and a data warehouse, where the data warehouse stores all the categorized, structured data spat out from the crawlers and ETL jobs. By including a data lake and a warehouse, you diversify your query capabilities to extend beyond structured and non-relational data. This is a simple view of the high-level architecture of a big data pipeline that is standard across all cloud vendors, each of which will have their own tools and services to implement the functionality at each stage. The data lake is where you will find all your raw data stored in something called a bucket. Preparation and computation phase is where your crawlers and ETL jobs get to work and spit out a data catalog stored in a data warehouse structure that is easy to query. Now that we have discussed the big data pipeline and the benefits of having it managed in the cloud, let's understand the key factor for success in implementing it in a business context. The value proposition of cloud transformations should combine long-term business value creation with pure IT cost efficiency. 70% of all digital transformations fail due to the central dogma that it is purely an IT issue and not a business strategy issue. Pursuing these cloud-based digital transformations only for cost-saving reasons are misaligned on the true value of cloud-based architecture systems. Approaching cloud solutions with this thinking means you are only expecting to cut costs from on-site data storage and not to leverage the opportunities for new revenue streams generated through the big data pipeline. These transformations must be approached from a strategic business perspective and not solely from an IT infrastructure cost optimization perspective. This means changing the way we think about big data. Storage is now cheap, and processing power is more accessible than ever. The excess data generated by business, traditionally thought a burden and a cost to be minimized, is what can and should now be monetized. To achieve this, even us software engineers need to think business transformation first, and not solely big data technology. It's easy to become infatuated with the technical innovations surrounding big data and cloud computing, but our so-called playing around with code doesn't work here. A structured and strategic approach is necessary for success. Starting with a technology focus can quickly turn your cloud transformation into a science experiment. Instead, You should start with identifying a clear and concise business use case, and then decide the best architecture and tools for the job. Remember, scalability is a key tenet to the cloud computing world. So starting with small ideas is a great entry point into the digital transformation that can allow you to scale it up later. What's arguably more important than focusing on the 5 V's of big data, volume, velocity, veracity, value, and variety, are the 4 M's of big data. Make me more money. Thank you.